Alright, this is Chapter 5, Lesson 8 on factoring linear expressions. I'll also be doing the guided practice off page 418. Some concepts we need to remember: GCF, greatest common factor. We're looking for the biggest number that divides evenly into both items. Prime factorization is writing a number or an item in terms of a product of its prime numbers and prime factors. And then to factor means to take out and write a number, or a monomial, I guess I should say, as a product of its factors. All right, so I'm going to remind you how to do that as we go through. I have these two things that I'm wanting to find their greatest common factor: 32x and 18. So you might remember that that they used to do this kind of with a tree. This is 32 times x. 32 can then be broken down into 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. That got a little ugly, but that tree was kind of long. 18, another way of showing it is this. You could divide 18 by 2 and you get 9. You could divide it by 3 and you get 3. And now I could write 18 as 2 times 3 times 3. And I could write 32 as 2 to the 1, 2, 3, 4, 5, 2 to the 5th power times x. Well, what do they have in common? They have 1, 2 in common. This has 5 2's, 2 to the 5th, but it has 1, 2 in common. So I could write that as 2 times 2 times 2 times 2 times 2, 2 to the 5th. We have 1, 2 in common. Guess what? That's all they have in common. That means the greatest common factor for number 1 is 2. When I go to the next one and look for its greatest common factors, I could write 27 as, well, 27s is 27 times s. And 27 is 3 times 9, which is 3 times 3. So once again, it's 3 to the 3rd times s. That would be the prime factorization. Show you that. Then when I do 54, you know what I realize? That's going to be the exact same thing, only with a 2 in there, but I'll go ahead and work it out. 2 times 27, which is just 3 times 9, which is 3 times 3. And so I could write that as 2 times 3 to the 3rd times s times t. So what do they have in common? Well, they have a 3 to the 3rd in common, and they have an s in common. And so I would say 3 to the 3rd, well, 3 times 3 times 3 is 27, and an s in common. So 27s fits in here, and 27s fits in here. So that would be your greatest common factor. All right, so let's try that again. Greatest common factor. I notice these two already have a c and a d in common. So I could just do 18. 18 is 2 times 9, which is 3 times 3. 30 is 3 times 10, which is 2 times 5. So I could write this as 2 times 3 times 3, and this one has 2 times 3 times 5. They have a 2 in common and a 3 in common. So that would be 6, and they also have a c and a d in common. So your greatest common factor is 6cd. It would fit in there 3 times. It would fit in there 5 times if you divided it out. All right, so the next one actually wants you to do that. I want you to divide them and factor them. So I want to find the greatest common factor, and you should be able to see these at this point. But I can see that 12 goes into both these. All right, so I would be basically dividing this entire thing by 12. It's kind of like the distributive property, only every term in the group gets divided rather than gets multiplied. So 36x divided by 12 would be 3x. I should show it this way. That's always the way I show it. And then 24 divided by 12 is 2. And then remind yourself what you factored out of it. This would be 12 times 3x plus 2. I've factored the 12 out, the greatest common factor, because it left these two things relatively prime. So if I did distribute, I would get 36x, and I would get 24. So I would get back to 36x plus 24. Factored, not factored. In jail, out of jail. Before the distributed property, after the distributed property. All right, so let's try that again. Number 5, I'm looking for something that goes into 4x and 9. Well, 2 would go in here, and 2, and then 3 would go in here, but they don't have anything that matches up, so that means really I can't factor these. They're already relatively prime. 4x and 9 are already relatively prime, so I just can't be factored. Alright, so let's try the next one. I would still do leaf change opposite. I'm trying to get you guys in the habit of that anyway. Leave change opposite. All right. So I'm looking for something that goes into both these. I see 2 goes into both of them. I could write this as 2 times 7 times x. I could write this as 2 times 2 times 2 times 2 times y. What do they have in common? They really only have a 2 in common, don't they? So let me pull that down here. When I divide this entire thing by 2, I would get 7x over here, and I would get plus negative 8y. I've got it factored. I've taken out a 2, and I've put them back in jail with nothing in common. 7x's, negative 8y's. Alright, so let's try this one. Factor one more. 25x plus 120. I see that 5 will come out of both of them, so let me divide the entire thing by 5. And then we'll see if these maybe something else can come out of them. So when I divide this one, I get 5x. When I divide this one, I get 24. Look back at 5 and 24, they are relatively prime. We have that thing factored. And so we have talked about how to find the greatest common factor. There are many methods of finding the greatest common factor. I just had you do it with prime factorization, looking for what they have in common. A lot of times you'll be able to see them. I showed you this one was an easy one to see, the 12 that just came out automatically. Sometimes they'll already be relatively prime, which means you can't factor anything out of them. If you want to put them back in jail, the only thing you can take out is a 1, 4x plus 9, and that really doesn't do anything because we know that anything times 1 is just itself. Alright, so that is factoring linear expressions.